Alright, we're going to use an LED in Scopy to make ourselves into a pulse width modulated DAC. So I'm going to set the frequency of a square wave to 1 Hertz, and you should now see it blinking off and on. The peak-to-peak voltage is 2 volts and the offset is 1 volt, and it's a square wave. And there's Scopy. Because I'm only going to 2 volts, I don't need a resistor biasing circuit. Alright, and so it's going on and off, on and off. I can see it on and I can see it off, just like you know, a step response. Alright, now I'm going to increase the frequency to 20, and I can see it flashing. Okay, but I can kind of see it turning off. At 50 it looks pretty solid, but the camera, it's discrete time, and it could be sampling at random times compared to when the LED is going off and on. Alright, and so that's 100 Hertz, still a little something on the screen, but looking at the LED directly, I don't see any flashing. Okay, and at 1 kilohertz looks solid on the screen and to my eyes. Now, our eyes are filtering out the harmonics of the square wave, right? And we're averaging the DC part, which, you know, is half of the intensity. The LED is nonlinear, so it's, even though half of a 2 volt peak to peak 50% square wave would give you 1 volt, the LED will not turn on at 1 volt. So we're averaging the intensity though. So let's bring the duty cycle. As I'm changing the duty cycle, it just blinks. Alright, so the duty cycle is now 10%, right? And so it's a lot less bright than when it was at 50%. Alright, that was 20%. You should have seen a little jump. 30%. Oh, that was 100%. That's 30. That's 40. Okay. 50. I'm just going to go up to 100%. And so, as we change the duty cycle, okay, the DC average changes, and that's what our eye is picking up. Now that's 90. Now I'm going to go between 90 and 89, and it blinks because I'm changing it, but I don't know. It's not big enough for me to tell, at least under these light conditions. So you're kind of seeing, you know, an effect of how accurately I can tell a difference. And so there's a limitation. But really, our eyes are acting like a low-pass filter. You can also look up persistence of vision. And since this LED is being driven by a pulse width modulated circuit, right, and we're seeing at a kilohertz a constant intensity as we keep the duty cycle constant, we are pulse width modulated DACs. Now if you wanted to have a fade in and fade out, you would just change that duty cycle slowly over time, and that's that.